This video is going to be Chapter 6, Sections A, B, and C, which are on sequences and series. And the first couple, A and B, are pretty short. They're introductory. And then Part C is on arithmetic sequences. So first of all, in mathematics, there are patterns all over the place. And it's really important for us to be able to recognize the patterns and describe them. So and sequences and series are definitely consist of patterns. So a sequence is a list. It's a list of ordered, or I should probably say an ordered list. So order matters. It's an ordered list of numbers, and it's defined by some rule. So there's some pattern to it. Ordered list defined by a rule. The terms are the members of the sequence, and sequences can be either infinite or finite. So finite lists obviously have an end, and then infinite go on forever and don't stop. So first of all, let's do example 1. And we have the sequence 14, 17, 20, 23, ... on and on and on. And the first question is to describe this sequence. When you're describing the sequence, you can, well, first of all, you want to notice the pattern. And things to look for are whether it's you're adding each time or subtracting, each time, or maybe you're multiplying by the same number, or you're dividing by a number, or maybe you have a sequence of squares or a sequence of cubes. So whatever it is, you have to look and try to find it. This one, it's probably fairly obvious that it's going to be, a sum of 3 each time. Each time you're adding 3. And you're starting with 14. So you would say it starts at 14, and you add 3 each time. Add 3 to get each subsequent term. I'm trying to make it sound nice. And then you could also describe whether it's infinite or finite. So it's infinite, it goes on forever. And that's that. And then another question would be to list the next 2 terms. And since we're just adding 3, then you would add 3 to 23, and we would get 26, and then we'd add 3 to that, and we would get 29. So that's example 1. And guess what? That's all section A was. So it's very straightforward. Now we're on to section B. Section B, oh, don't do that, is the general term of a number sequence, is the title of that one. And what that is that's basically the formula, the general term. So the formula would give you the value for any particular term. And we can define sequences in 4 ways, and it happens to be the same 4-pronged approach that we use in calculus. So if you remember that, the 4 ways to describe a sequence are, number 1, algebraically, which would be with a formula. Secondly, graphically. And these are in no particular order. Numerical, or numerically, is the other one, or the next one. So that's like a table of values. And the last one is verbally, or with words. In calculus, we say verbally. And that means writing out a sentence. That's probably the one that maybe students are the most reluctant to do. And in this case, I was going to look at this, listing terms. Okay, so I was kind of looking at the way the IB did it. They said listing terms. That'd be the same as the numerical, the list. And in this case, it's a list. It's not really a table. So I was kind of thinking more like along the lines of calculus. And then the general term is called U sub n. At least in this book. Might be A sub n, depends on which book or which person you're talking to. And the cool thing about this, or one thing that you really do need to know, is the n's start at 1. So n is going to be 1, and then 2, 3, 4, and so on. So make a note that we start with 1 always. And also, because we're counting, we are actually using integers for our n's. So the way we say that is n is an element of the integers, and not only all integers, but the positive ones only. So we say n is an element of z to the plus, the positive integers. So that's the domain. So, oh yeah, by the way, the n are the domain. The domain is the n's, and then the range would be the actual numbers in the sequence. The domain is not explicitly stated. It's usually you just see a list of numbers, and those are the range. But then the term number is the count, so to speak, is the domain. And then an example of a general term would be something like this, 2n plus 1. And so then what would you start with? You'd start with n equals 1. So that would be 1, 2 plus 1 is 3. And then you'd plug in n equals 2, so that's going to be 4 plus 1 is 5. And 3 would be 6 plus 1 is 7. And at this point, you could probably see a pattern here. These are going up by 2, so it'd be faster to just add 2 to each one and keep on going. That was section B. Now we're on to section C. See, these are going by really fast. Section C, though, has a lot more in it. And that's on the arithmetic. It looks like it would be arithmetic, but I say arithmetic sequences. And you probably remember these from pre-calc. These are the ones where you're adding or subtracting to get the next term. Add or subtract. As opposed to the geometric ones where you're multiplying by a common ratio. So in this case, you're going to be adding or subtracting. And here's the formal definition for an arithmetic sequence. U sub n is arithmetic if and only if, from geometry, so this is a biconditional, u sub n plus 1 minus u sub n is the same value no matter what. So for any two numbers in the sequence, if you subtract them, you'll get the same value, and that's called D, and that's called the common difference. So D is the common difference. And there's a really interesting result that happens because of the name, arithmetic. So what we're going to do is we're going to find the arithmetic mean. And that's just a plus b divided by 2. Or, adding up all the numbers and dividing by how many there are. That's what the arithmetic mean is. It's just the mean that you're used to working with. So if A, B, and C are members in their sequential members, consecutive, that's the word I'm looking for, consecutive terms or members of a sequence, show that they are, oh wait, I meant to say arithmetic sequence. Then, we're going to do a little math here with that. If that's the case, then if I was to take B and subtract A, I would get the same number as doing C minus B, right? Because all three of these numbers are equally apart, equally spaced. So now, let's solve for B, because I see there's a B in both of these, so I'm going to add B. So I'm going to have 2B on this side. I'm going to add A to the other side and get A plus C. And then I'm going to solve for B, and I'm going to get B equals A plus C over 2. That means B is the mean, the arithmetic mean of A and C. And if you look in the list here, that means that B is the mean of either two numbers, the two numbers on either side of it. Isn't that cool? This is super important. Remember this. It's going to come in handy. Now, the general term formula for arithmetic sequences. And obviously for geometric sequences there's going to be a different formula. So this is something you should memorize. It's probably on your formula sheet, but it's u sub n equals the first term, u sub 1, plus the difference times the previous term, essentially, because n minus 1 would be the previous term, previous to this n. So this is something that we're going to use frequently when we're working with arithmetic sequences. So for instance, here's our first example. Consider the sequence 2, 9, 16, 23, 30, ... and show that it's arithmetic. That's the first thing. So first, what I was going to do, I was thinking, oh, let's do that arithmetic mean, because that was really cool. So I'm going to try that. Let's show that 9 is the arithmetic mean of 2 and 16. So 2 plus 16 divided by 2, does that equal 9? 18 divided by 2, yeah, that's 9. And then you could just work your way up. Let's show, I'm just going to skip up a bit. Let's show that 23 is the arithmetic mean of 16 and 30. So the average of 16 and 30, that's going to be 46. 46 divided by 2 is 23. That's just the thought. That's what came to my mind when I saw this. Now, looking at the IB book, what they did instead, and on the IB exam, I'm not sure if you did have this problem. I'm guessing the way I did it would be correct. I mean, it is correct. So hopefully the IB graders would be open to a couple different ways to prove this. You could also just show the common differences. So 9 minus 2 is 7. 16 minus 9 is 7. 23 minus 16 is also 7, and so on. So you're showing that they all have the same difference. And what you need to do here also is you need to say, you have to actually state it in words since you're showing. You would say the common difference is 7, and the initial term is 2. So you're describing the sequence as well when you're showing it. Next, on that same, well, maybe I'll go back. Let's go here so that we don't have to change slides, because there's another part. So letter B, and I have to look in the book to see what it says. Got it here handy. Letter B asks, find a formula for the general term. So we're going to find u sub n. Okay, well, I've got that handy here. I know that I need my first term, which is 2, plus I need my common difference, which we found to be 7, times n minus 1. And then you can simplify this, which I noticed our book does, so I'm guessing the IB wants us to do that. We can do that in our head. We're going to have 7n here, minus 7 plus 2, so minus 5. Letter C asks, find the 100th term. So that means 100 is in the domain. That's the n value of 100. So I'm going to use my formula here. U sub 100 is 7 times 100 minus 5. So that's 700 minus 5. 695 is u sub 100. So with the formula from B, it's very easy to answer questions like letter C. And then let's ask this last question, I'll skip to this one, 2, 3, 4, 1, a term in this sequence. And to do that, so that means that's in the range. That needs to go in for y, or in other words, u sub n. So I'm going to come up here where we have a little bit of workspace. We'll change colors. So we're going to be plugging 2, 3, 4, 1 in for u sub n. And we're going to check to see if we get a term number. In other words, n needs to be an integer for this to be, n has to be an integer in order for 2, 3, 4, 1 to be a term. So we'll add 5, 2, 3, 4, 6. I don't know, is that going to be, so let's see what that equals. Divide those, 2, 3, 4, 6 divided by 7. I'm a little suspicious of this one. 2, 3, 4, 6. Trying to remember if 7 ever ends in a 6. So n is a decimal. 335.14, blah, 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 blah. That means this is not a term, because this is not an integer. So we would say no. And then this is the work that proves it. That was example 2. We have quite a few examples in this section. I am going to work them all. And this is stuff you've all done before in pre-calc, so hopefully it's review for you. This one's a fun one. I enjoy this one. Find k, and we've got 3k plus 1, k, and -3, and these are all consecutive. They're all in order, and it's an arithmetic sequence, so we need to know those two things, and we get to find k. And you know, there's a couple ways you can do this. Once again, what popped out in my head was, hey, k is the arithmetic mean of these two out here. So let's set it up and find it out. So that means k is equal to the sum of 3k plus 1 plus -3 divided by 2. And I see I've got 3k minus 2 over 2. Multiply both sides by 2. Subtract 2k, add 1. So that means 1, or k equals 1. That's weird. Is that really what I got last time? I did work these problems ahead of time. I just don't remember that being the answer. Oh, it isn't. What did I do wrong? I made a mistake. 3, maybe I made a mistake before. Let me just check this out. 3k plus 1 minus 3. Let's see. I might have made a mistake here. Divided by 2. Oh, this is a 2. I didn't copy it right. That's where we went wrong. I knew that didn't sound right. And then, so subtract 2k, I'm going to get k, add the 2. K equals 2. And then you can check it by plugging it back in and making sure it gives you an arithmetic sequence. So 2 times 3 is 6, 6 plus 1 is 7, and then 2, and then -3, and these are going down by 5s. So that works. There is another way you might have done this, and that would be to note that if you take any two terms in subtract them, you're going to get the common difference of d, and that's going to be the same every time you subtract. So you could have said k minus 3k plus 1. That common difference would be the same as -3 minus k. And then solve that. I'll leave that up to you, and you will see that you also get k equals 2. Next example. Example 4. Find the general term u sub n when u sub 3 is 8 and u sub 8 is -17. So where should we start? I would start by writing down the formula for u sub n, so I have a kind of a template or a path to follow. So that's the formula. It's handy if you have it memorized, so that you can, because you're going to want to have it handy. And then we don't know u sub 1 and we don't know d. Those are the two things we need to find. There is the fast way to find d, and there is the slow way to find d. And of course, we want to do it the fast way, right? The fast way is to notice, so going from 3 to 8, that's 5 terms. So you can do -17 minus 8 and get the difference between these two numbers, and then divide by how many terms. So that's a difference over 5 terms, 8 minus 3. And then that gives you -25 over 5, which is -5. So that's D. The book does it the long way, and you can look in the book and see that for yourself. What they do is they plug 8 in for u sub n and plug 3 in for n. And then they plug in -17, and 8. You get 2 equations with 2 unknowns, and then you have to solve the system of equations, and you end up getting D. So it's this long process. But it's really not necessary, because you can quickly find D this way. And then, once you do that, you can plug that in here. And now you can go and choose one of these points. I'm going to choose, or one of these terms. I'm going to choose this one. That means the n is 3 and the u sub n is 8. So I'm going to plug in 8 for u sub n. U sub 1 I don't know. And then n is this 3 here. And that's all I need, because I only have one unknown, so I only need one equation. So 3 minus 1 is 2. 2 times that's negative 10. Add 10, I get 18. Whoa, don't do that. It always wants to switch on me, doesn't it? I think I write too fast for it. Now, okay, so now U sub n means the actual formula. So U sub n is, and we go back and plug in 18 minus 5, and then the n minus 1 is part of the formula. So here's our final answer. I do recommend checking because it's super fast, and we do make mistakes. I already made one today. You can check with this term here. So I can plug in negative 17 for my U sub n equals 18. This is a question. Minus 5 times the n is 8, so 8 minus 1. So that's going to be 8 minus 1 is 7. 7 times 5 is 35. 18 minus 35, let's see, that's 10, 5, 15, 16, 8, or wait. Yeah, 15, 17. So that is negative 17. Doing some subtraction there in my head. So it does check. Yeah, that's kind of a fun problem. That's a classic too. You see that in all the pre-calc books. Classic problem. So expect to see that one in the future. I could see them putting that on the test. Example 5. Insert 4 numbers between 3 and 12. So that all 6 numbers are in arithmetic sequence. Let's see. So again, you know what I did? I always want to make sure I don't make any stupid mistakes. So I did 3, and then I kind of just made up A, B, C, D, and then 12. So between 12 and 3, what we need to do is we need to find the common difference, and that's used 1, 2, 3, 4, 5 times. So just do 12 minus 3 divided by 5. Just, I don't know how to explain that. Hopefully it's common sense. You have this whole interval from 3 to 12, and you're dividing it into 5 D's, if you will. There's 1, 2, 3, 4, 5. Oh, that's supposed to, yeah. So 12 minus 3 is 9. 9/5. Let's see, that's 5. That's 1 4/5, or 1.8. Now that's the D, and that can be a decimal. That's okay. That's okay. We're good. We're okay with D's being decimals. The only things we can't have as decimals are the n's, like n equals 1, 2, 3, 4, 5. Those have to be integers. These actual terms, these are the range. They can be decimals. That's okay. So the terms can be decimals. The n's can't, because that's like your count. First term, second term, third term, fourth term. We can't have like a 1.3 term. That doesn't make any sense. So it is okay to have decimals. So now we're just going to add 1.8 to 3, so that's 4.8. And then add 1.8 to that, and so on, and you'll get all your numbers. So just because I'm not super fast at adding stuff in my head, I am going to save your time by writing down the answers for you. And you might have already done this faster than I can write them. So those are the 4 numbers. And that brings us to the last example. If you're feeling pretty comfortable with this, you could actually stop right now. You don't have to do this example. This example is more of the same ideas. It's just in a story book, you know, what do you call those? Story problem form. So I will go ahead and do this so that if you want to watch it, you can. And this is the last example. Looking on page 158, I didn't take the time. I should have probably typed it up ahead of time for you. Ryan is a cartoonist. His comic strip has just been bought by a newspaper. So he sends them 28 comic strips he has drawn so far. So he sends them 28 comics to start. Each week after the first, he mails 3 more comic strips. So 3 comics each week after the first. And the first question is, find the total number of comic strips sent after 1, 2, 3, and 4 weeks. So after the first week, there are 28 comics. Then, after the second week, so this is the total number that the newspaper has. They've got the first 28 plus the next 3, so that's 31. And then the next week there's 3 more, so that's 34, and then 3 more after that, 37. And have I gone far enough? Yeah, 1, 2, 3, 4 weeks. So that answers that question. Letter B. Show that the total number of comic strips sent after n weeks forms an arithmetic sequence. So that's the same question we answered earlier, show that we have an arithmetic sequence. I'll do it the way the book does. I'll do 31 minus 28 is 3, 34 minus 31 is 3, 37 minus 34 is 3. So D is equal to 3, and U sub 1 is 28. It's kind of silly in a way because these numbers are based on the fact that I did them using this information right here. So it's kind of circular reasoning in a way, I think. I suppose I could look at what the book did. They just said pretty much what I did. They just described the sequence there. They said they just said the common difference is 3. Yeah, just like I did. Okay, letter C. Find the number of comic strips sent after 15 weeks. So at 15 weeks, how many comics? So basically you need to know, is the 15, where does that go? Well, for one thing, I don't have my U sub n yet. I think I'll make that. U sub n. Remember, that's U sub 1 plus D times n minus 1. U sub n equals, now this is easy because I know U sub 1 is 28. I know D is 3. I have my formula. Now, at 15 weeks, which variable is that? Well, that's the count, the number, so that's n. So then U sub n is 28 plus 3 times 15 minus 1. That's 14 times 3, which I have to do on my calculator. 14 times 3, that's 42 plus 28 is 70. So at 15 weeks, they should have 70 comics total. And then the last question is, when does Ryan send his 120th comic strip? I'll kind of come over here. What did I say it was again? 1/20th. The 1/20th comic, which week is that? Question mark week. Or what would we say this? Week blank. Well, this time they're giving us the U sub n is 120, so we're going to plug 120 in for U sub n. And we'll go back to the formula 28 plus 3 times n minus 1, because this time we're trying to find the week number, which is the count, which is the n. And we will distribute. Let's subtract the 28 too. So that's going to be 92, 92. And then 3n, we'll distribute the 3n while we're at it, or the 3. So then I'll add the 3 across, so I'm going to have 95. Divide by 3. 3 definitely does not go in there evenly. See, it goes into 9 3 times. It goes into 5 once, with 2 left over. So 31 2/3. That means, and the way to interpret this is, so 31 would be the 31th week, and then you're working towards the 31st week has passed, and now you're on to the 32nd week. So it's during that 32nd week that that the newspaper has 120 comics. Because they get it sent at the end of the week. So at the end of, you want to round that up to 32 basically. Okay, we are done.